All right. So yeah, it's been quite some time. I haven't really like looked at the code in a long time, to be honest. It's like kind of like when you're almost finished with something on the cusp of being finished, at least for me. I just kind of lose interest when like I feel like all the hard stuff's done. But anyways, I mean, who knows? Well, let's find out. Cause like after like I kind of like over these past few streams have like kind of done a lot of written, well, not a lot, but written like a considerable amount of code. It's all untested. Everything's untested. Like all my commit messages are like kind of like, let me refresh this. Last commit is January 30th. It's a leap year this month. February 28th. So like wait, what's my screen time? 10 hours. Not bad, not bad. It used to be like 12, 11. Yeah, like initial, like everything's like kind of like a sketch and hopefully an initial and like comma untested, like that's untested, that's a fix. Initial tentative, like everything is kind of like everything is like written with doubt. So now let's quash these doubts hopefully. So I want to debug everything. So where was I last time? What was my last stream? I think I was doing let's see what I was doing. Tensor, so probably model.fit, right? Like training. Yeah, .net.ts and train.ts, example, value output, yeah, 10h from -1 to 1, good. Convert, so I made this kind of, I removed exports, I made it private to net.ts. Convert policy to tensor, wait, that makes it private, this one. What does this do? Convert policy to tensor. So we have the policy, which is like move and probs. And then we, so this is a zero. This is a zero. We're just pushing all zeros for all the columns. Because again, tensor, even if the column's full, it just has to be number of columns. Even if the columns are full, their probs just be zero. And for all these things, we just kind of like, yeah, we just convert this to tensor. That's literally it. It returns a tensor of policy data and then the shape. And the shape of this tensor, right, this policy tensor is the number of columns. That's just the shape. Okay, yeah, fine. I believe we're using this somewhere below in train model. I remember like kind of like looking at the documentation for concatenate and stack. Now I did like kind of look at this myself just to convince myself of its correctness. And then, I mean, of course we have to debug it. So I'll probably like put some breakpoints here, but like it makes sense to me at least. But we will see. We will see, of course. We will see. Like right here in train, we're logging the history. And okay, yeah, fine. And then train.ts. So lots of stuff was done last time. Some good stuff. So like hopefully we're finished, right? Just train. Oh wait, train model. So like this is the actual train, right? Let's go down a bit, see what happens. Self-play game. Yes, like self-play game. Okay, so that's a bug. Self-play game has to return example, right? It's not returning anything. Okay, but anyway, so once we self-play, right, like in our train, we do self-play, and then we get our examples. So in to do, we have to return the examples. Then we push them all. Oh, then here's a bug, or not bug, but remember we did symmetries? We should like have some code to like do the symmetries too, right? So that's another thing. Then we train the model, and then another thing missing, which I didn't really do last time, is well, we can do that later. Actually, let's put a breakpoint maybe. But like now that we trained the model, we have to actually save the model. Like like the model is just in memory in this code, but we have to like save it in our model directory and like the JSON, like the weights.bin or whatever, like the weights and like the topology is saved, but just the weights after training, we get new weights, right? Just back propagation, whatever. Okay, so we're almost done. We have to put some breakpoints in this train function, especially in self-play. Like with self-play does the Monte Carlo tree search, right? Like it does the do MCTS, and like that's the crucial part. And see how this Monte Carlo tree, we can actually like step like, okay, so I've been doing everything in Vim so far, but I think I'll use VS Code or something, and then like kind of I want to like have a visual debugger so I can like step through everything. But yeah, that's it. The idea is to put some breakpoints in this train function, and then kind of like dive into self-play game. And self-play game, I'll look into Monte Carlo tree search, and then boom, and then we'll start actually like doing it. Okay, so let's see where we at, right? Server. Yeah, I was just like playing against myself, just like dot run.sh, just to see it in action, right? And then I have like a server right here. Just refresh that. just play connect 4, boom, 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 boom. Yeah, I went. The bot's randomly doing stuff. Okay, that's very uninspiring. Let's just close that. Close that server. Get status. Origin main. Clear. Get log. Temporary commit on potential dimensions. Yes, that is exactly like what this thing is. So like everything is matching. Everything is tracking the remote. Get pull just to make sure that it's nothing else has happened. Obviously there won't, because no one else is committing to this so far, to my knowledge. Get status. Okay, good. So we have a clean slate, right? Okay, so now let's actually open up Visual Code and step through it, right? Code is just the shell command for this VS Code thing, which I added. Okay, so here's everything. Good. Okay, so then let us see what we have to be done, right? Inner train.ts. Okay, so first things first. Self-play has to return an example, so that's okay. Let's actually see the problems. Do you have problems here? Errors 1, yeah. Lacks ending return statement. Okay, good. So that's kind of nice. Okay, let's yeah, I have a Vim plugin, so I can like kind of do that. We just return the examples, right? Return examples. I hear something. Let me check outside my window. Okay. All right. So right now we're just returning the examples. So that's fairly straightforward. And now let's see the use of this function. Soft play is used right here. Yeah, it's nice that we can command and click it. And here what we want to do is do symmetries, right? Like here it's not just enough to do examples, but we have to like flip them about the vertical axis. So let's just add that right there, right? Let's look at symmetry.ts. We're exporting symmetries. Where are symmetries? Here, right? Let's go and click that. References for, how do I see the references? Export that. Where's the usage? I mean, I know I use it somewhere in a Monte Carlo tree search, right? Yeah, import symmetries, copy this line and put that in the train.ts, right? Like right here. Some symmetry. So we get the symmetries, right? So like the whole idea is to take this line and like kind of do something else, right? So like for let symmetry of symmetries, right? Symmetries. And like we want to like take these examples and like just kind of like we want to take the example and then like kind of run it across the symmetries. First one's identity, which is kind of a no-op, and the second one's flipping vertically. So then we want like a symmetry example symmetry, which is an example, right? Or actually, no, we should have the outer one be examples, right? Well, let me just check my phone briefly. Yeah. Okay. So then, right. Let's actually comment this out here. Let's just push that there and then like kind of do it over the examples, right? So like for let example of examples from game, right? So for each example, what we want to do is we want to apply the symmetries to it. That's kind of like the idea. So like then for symmetry, like, we're kind of like meshing the example and symmetry. So like we have an example, and then what we want to do is we want to create a new example based on the symmetry, right? Equals, and then an example is just a triplet, right? Of like the state, the policy, and the value. Where's example again? From .NET, right? Game state policy number. It's just a like an array with like a list with 3 entries. Name tuple, name tuple, game state policy value. So then what is this, right? We have like 3 entries, like some entry, in like three things, like something, comma something, comma something. The first thing is the game state. So example 0, right? We have like example 0. Yeah, just like 2 plus that. Example of 1, example of 2. So example of 2 is just a value, that's fine. Then we want to take the symmetry and like kind of flip it, right? So it's kind of like, so it's like a symmetry dot and transform, yeah, transform game state. And what is the game state? Well, precisely this, right? Oops, sorry about that. Like that. And then this will be symmetry of transform policy, right? Oops. Transform, wait. Dot transform, wait, is it transform policy, transform inverse policy? I think it's transform policy. I just got a message. Oh. Hold on. Okay. Where was I? Right, so then transform the policy, right? I want to auto select transform policy of that, right? That's just asking for it. Anyways, I'm just being an idiot. An example 2, right? Like we take this, wait, let me look at symmetry again. Symmetry.ts. So like what are the methods that symmetry offers? There's two main things. It just transform the game state, transform policy. And then transfer inverse policy is used in like the actual Monte Carlo tree search, mcts.ts, right? Transform inverse policy. Where like when we're actually creating the node, right? We have to actually like we can create it. Yeah, transfer inverse. So inverse policy is only used in this one case, but the rest is just the typical methods. Just like the main public methods, transform game state, transform policy. Like these two are just used right here in train.ts, right? So just do that. Okay, yeah, that looks good. So that's our example symmetry. Anyways, that's great. Then what? Well, what's the next step? For example symmetry, and then what do you want to do with this example symmetry, right? We want to put it into our example. Instead of examples that push this ... nonsense, let's just actually like push it right here. Examples.push example symmetry. Let me just check my phone. Okay. Anyways, yeah, so where was I? I was here. Examples were like instead of like doing the examples, we want to like take into account the symmetry. So for every example, what we want to do is we want to like do the symmetry on it, right? To like get like expand it. So like from one example, we get two, like the identity, which is kind of redundant, and then like the flipped one, right? Like if you look at symmetries, then we have like the identity and flipped horizontally, where like see these lambdas passed in there, right? Like the transformation functions. The constructor takes in the functions and just stores them, like binds them to there, and then when we're transforming, we just use the lambdas we passed in. Simple stuff, actually. So then we just push it there, and then now we get so I can delete this line. It's no longer needed, right? Does this look good? Yeah, well, it looks good. It looks good. Then we await the train model, and then we have to save it, right? Okay, whatever. I'll just put a breakpoint there for now. Second, let me save it there, or save it. Okay. And then how do we save it again? How do we save that? I think like in net.ts I have some saving code, right? Like yeah, await model.save, something like that. Let's just copy this line right here, paste it right there, I guess. Save that. I think there's a terminal here somewhere. I could use my own terminal, but get status. Yeah, there's like we're modifying that. Right. Let's drink some water. Okay. Oh wait, what? Just quit that nonsense. I don't need that distracting me. Okay, now let's actually debug. So right now, like, yeah, just was one number iterations, one game per iterations. Fair enough. Let's look at MCTS. 100. I could lower that. CPUCT, whatever. Let's just, yeah, it's fine. Let's just, I want to do some debugging. Like, okay, let's just like put a breakpoint right about here. Actually, wait, no, we have to actually pass in this, like, no, train, we have to actually, like, yeah, we have to actually call it, right? This is just a definition. We have to actually invoke the function, right? Like, just train. You have to pass in the model, right? Train. You know what, let's just actually do something else. Instead of this, what we can do, wait, what's train model again? That's from .net, right? I mean, yeah, from the /net, ./net. Train model. Yeah, I remember as like kind of like doing a lot of like kind of really kind of looking into how to actually like, you know, like format the input into like tensors, input and the y's, x's and y's. Because again, like this thing already had like a zeroth, like the num, whatever. I extensively talked about this and convinced myself of the correctness last time, and a bit off stream too, actually. Like I just thought about, anyways. So the thing is, it's pass the model. Like, where I think game does it, right? Like, we have to like see how to create this. In fact, let's just actually do it like here. Let's actually get rid of that. Let's just actually like do like this. Like, let's do like let model and like kind of like make that nothing, right? No arguments. Put it here equals 2 and then something like that, right? So we can just call it in line 39 right here, right? Like this one. Wait, no, not command rate like that. Okay, so like something like this, right? It's like kind of like await like load layers model or something like await, right? Like I know game dot. This is like the JS from the browser side. There's some red lines. Well, I don't care. For now, I mean, I know it compiled. Like, where do we create the bot, right? Like, the bot. Yeah, we're right here. Sorry, I almost use Vim. I haven't really used this in a while. Line 89. Okay. Line 80. Wait, what the hell? Why is it going here? A constructor. Okay. Game.ts line 89. So 89 GG. New bot. Await tf.load like that model. Yeah. Okay. That looks good. just yank that and copy over here, right? Oh, I have 208s. Well, that's not good. Just delete one of them. Okay, that looks good. Okay. Okay. All right, so now, like, how do we do, so I know we need source maps, right? I don't want to use a TS config. I just want this to be purely command line based. Source map file. So this is source map true, right? Or actually, no, I want to use the debugger, right? Like this run configuration. So I think I need to create whatever, like, what do you call that? Actually, let me just Google it for VS Code. I think they have their own stuff, right? Like everyone has their own stuff, right? You need source map. tsconfig. Okay, let's create a new file, tsconfig. Let's create a new tsconfig. It's called tsconfig.json. I'll cave in and create one, even though I didn't want to. I don't like config files. Okay. Copy that. Copy that. Let's just delete all this stuff. I don't care about that. I don't want any output directory. I know mine's cluttered, but I don't care. I'll just accept it. Source map troop. Actually, I should add it into my git ignore too. Actually, right? Like the source map. Let's just first run this, right? Let's just first run it. Let's put a breakpoint right. Let's put a breakpoint right here, right after we load the model, right? Let's just do that and run. Moment of truth. Node.js because we're training it. And there's an error. Cannot use import statement outside a module. Train.ts line 3. Oh, I have to first compile it. I see the issue, right? TSC. Status. Okay, so these are all the unfiled.js. Let me just add this into git ignore. Let me just first add. These are bugging me, right? These map files. Let's first add them. You have to first actually add them. You have to first do TSC. Only you have to first do TSC to get the JS files and then do it. Right? I can't just like do train.ts. You have to first add them. You have to first generate the .map files. Okay, let me just first add these to here. Let's kind of copy that. And then I'll like do that there, right? .js.map. Yeah, what I'm saying, sorry about that, is like, you see like there's like kind of like the issue here. Like I forgot to actually like run the TSC on it to compile it and generate these maps. So now from these map files, they should be able to like figure out everything should work now. Hopefully, we will find out. I've done this before in different projects. Shouldn't be that hard. Debug console. Why is this not? Fail to parse URL from /model/model.json. Wait, what? What? Wait, TF layers, TensorFlow, wait, what? Shouldn't it be like, this isn't TF.js layers, right? But aren't we using TF layers no GPU? Yeah, shouldn't this use TF.js no GPU? Why is it using... What? Okay, let me look at, let me just... Okay, let's just like search load layers model, right? Just load model node, right? Wait, let me first clear out, let me look at my tabs. I have so many tabs open. Let's go to the first tab. This one, 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 document, I can, well, this one, what is this? Fit. Yeah, I remember looking at that. Okay, that one, whiteboard, whatever else, to delete that. Sure, I don't want to delete anything. Let's keep it open even though it's closed. This one, what is this? Yeah, yeah. So save and load model. Just open that new tab. That's what I'm looking for, right? I have to look at it into loading it on the Node.js because we're training it from Node, right? File, path to my model, my .json, like the actual, yeah, .json, right? And then we'll reference that previously. Yeah, like when we're saving it, we just specify like the directory, but then when we're loading, we have to actually like index into the, like we have to kind of go into the JSON folder, into that, the bin, right? Yeah, let's look at the model, right? We can just do that here, right? It's just right there, the model. Model.json waits.bin, right? Like, simple. ls, model, ls. Yeah, I think an output directory would be nice to like ignore all the .js and .js.maps. We only care about TS, but whatever. Get status, and now like it's much cleaner. First we had all this nonsense, all the map. Now we kind of added to get ignore. Let's just maybe just do a quick git commit add git commit add ts config some hopeful fixes to train.ts. Get status. Oh wait, what did I just do? I just try to commit some nonsense? I have to first do git add and then commit, right? Let me add some more before my commit message. Well, I mean, let's just first like kind of like do some more stuff, right? Yeah, there's nothing wrong with this. Do you have like, we're just like kind of doing dot slash. Oh, did I need to do like the file thing? Like file, like the file protocol, like file colon. Yeah, because this like copied from game.ts, right? Game.ts, which is line 80 something, 89. It's like, this is like kind of like they use the fetch, like the browser fetch. This TF is from TF.js. You know what? Maybe I should just kind of like make everything the same, right? Like make all these TFs just like one thing I could just do is like what does .NET TS use, right? Its model definition. TF job. Yeah, I know. I think I should make them the same, to be honest. They should be consistent, right? Like they should all use the same thing. Actually, yeah, let's just temporarily do that. Status. Yeah. Let me just commit what I have so far. Status, get push, yeah, whatever. Let's just push it. But anyways, I'll just use this file protocol, right? File dash dash. Let's copy that. Wait, what do I do there? And then in the like that thing, save file dash dash. Right? When do you save it? Like in their .NET, right? How do you save that? .save file colon dash dash dot slash model, right? So then here in train, let me just make this more full screen. Delete that. Train.ts. Wait, let me just look. How do we enable preview? Not something. Never mind. So train.ts, right? Yeah, file colon slash forward slash dot slash model. Wait, this isn't train. And then here what we want to do is we want to take that there, right? I kind of copy this, right? Into here. I can go down, go there, actually. That's probably more faster. So in here, we kind of go there, and then we just kind of put that in there, right? After this one right here. And delete this dot. Like that. And now let's run it and see if that gets rid of this this type error parse URL nonsense. I have to first do TSC on it. Important to compile it. Okay, good, it compiles. Run debug. Boom, we got our model. We can actually look at our model, right? It's our TensorFlow model. Okay, great. So let's step into it. Let's just kind of step here. Examples, okay. Number is just 1, right? Yeah, it's just 1. I can hover over it for it to show me. Yeah, it's showing 1 there, right here. Okay, cool. Self-play game. Okay, here's the moment of truth. Let's step over it and zip into it. And the debugger crashed. Let's see what the message is. Cannot read properties of undefined reading model. Self-play game model? Model? What? Okay, so let's put a breakpoint here. Model. Fail. I create node. So self-play, do MCTS, create node. So then somewhere here, okay, we have to step into this function. So let's delete that one and run and debug, right? Let's look into here. Let's step into that. Self-play, okay. Self-play game, example, sure, why not? Do MCTS. So here was in the call stack. So somewhere here is the problem, right? That's our model. Model is not undefined. Let's go into it. Okay, we create the node, sure. Step over that. And error. Okay, so now let's put the breakpoint here. And let's run debug. Come on, do it. It's taking so long. Node.js. Oh, wait, no, it's the wrong file. Sorry, I have to run and debug train.ts. My bad. Okay, step. Create node. Yeah, so the step into somewhere here, right? Or is it, no, another breakpoint? Sorry about that. Train.ts, again, run debug. Again, step into this. Okay, our model. Okay, fine. Game status. So create nodes when we create it. Game status, ongoing. Okay, symmetry. Sure. So right here, it's like, if it's not ongoing, it's a leaf node. Like, yeah, if it's terminal. But in this case, it's the root. Like, it's obviously, like, let's just look at our game state, actually. Right? Just an empty array, right? Like, no ones or twos dropped in here. Ones, and remember, because of like the game state, like the enum, right? 0 is empty cell, 1 is player 1 has a cell, has a coin there, and then 2 has a chip there. Okay, so in get policy and value, this dot model, that's any. Wait, what? Oh, I see the problem. Model. It's not this dot. Okay, that's the issue, right? Right here, when we do get policy and value, I think that's the issue, right? Step into that. Transform game state function. Flip state. Wait, what? No, let's just go out of this one. Out of that one. What? But I think I know the issue. Yeah, let's just do create node, right? Where's create node? The point is that like it's this dot model, but it should just be the model that's passed in here, not this dot model, which is just, let's just delete that nonsense and save it and go back to train. Let's, oh yeah, first gotta do TSC, compile it. Compile it. Okay, it's compiled, then run it. Okay, let's just kind of step across it. Let's just like get rid of this breakpoint because I think it's done. Back out. And error. Yes, an error message. Should not see this message. It is not this player's turn yet. Well, that's kind of bad. I thought this should never happen. Can I for gamestate.ts? Okay. Gamestate.ts. Line 118. Should not see this message. Okay, so apply move. Okay, let's actually look at MCTS then. Let's actually step through it and see what's going on, right? It's the best way to do stuff. Let's step into it. Like what we're doing. Like we're self-play game, do MCTS, search. Okay, let's put a breakpoint in search actually. Let's see our breakpoints. Let's remove all these breakpoints. Let's put some breakpoints in the search function, the main highlight. Actually, let's just take a step back and review the search function because it's been a while. Because like this is like kind of the heart, right? This is the search function. Like if you look inside like that guy, like this whole thing, like this is the centerpiece. This is mcts.ts, but like this is Monte Carlo tree search, right? Like this is like the crowning thing. So given search, we recursively perform one full iteration of MCTS, return the value contribution. I explained this at length. Why I call it value contribution, not value contribution. It's like the contribution that gets bubbled up to all like the parents. It's like MCTS with a bunch of trajectories, like a bunch of arcs from root to a leaf, all right? And just kind of like does that a bunch. And like each time it goes, it kind of backprops that same contribution all the way back up the trajectory it takes. Return value contribution from the perspective of the player's turn it is. Okay, so that's the whole negative sign business. Like kind of right here, terminal -1, good. Precondition node exists, that's a precondition. And then it's like it exists. And then we have will create node to create it. It's been visited. Okay, so node is not terminal. If the node is an end, that means we've already cached it. I mentioned there's an optimization. We should return -1 dot its terminal value. -1 to flip it, right? Let's just say that we call search from the perspective of a node whose game state, right? Like the MC node has a game state in it, does it not? Yeah, it does. MCTS. The node has a. Oh, this is a JS. I never want to see that. I just want to see CTSs. The MC. Oh, it's the same file. Has a game state, right? So that one has a game state, and the game state has whose turn it is player 1 turn, right? So let's say that's true. It's player 1's turn for the assumptions of this specific outermost call of search. Like when you start playing Connect 4, it's player 1's turn, right? If the game's ended, then we just do -1 times the term. So like, let's say that the game state, this node's turn, is +1, right? That means that like we return -1. So like the caller would be search on player 2's turn. So then it would see -1, which makes sense because if you're good for player 1, you're bad for player 2. So these two lines check out. Then best edges is that. Okay, sure. Then -infinity, just like int dot in Java. Okay, that sounds good. Then for edge in edges, we take the score. We get this UCB score, which is defined here, which is just like if it's num but 0, we just return 0, or else Q score subdivide num 0, right? Like we don't want to divide by 0. Like it's like the initialization is kind of like somewhere here, right? Right. So I mean, anyway, I'm confident of that. But we get the Q score, and then we kind of like we kind of keep track of like which edge, like which action, which edge performed the best in terms of like the Q score. And then I mean not the Q score, the UCB score, right? This score thing, whatever whatever like this U is, right? Whichever one is the max, right? We just choose the best action to take, the best edge. In this case, action is edge in my code, right? So then we choose the best edge, and like it's a list because what if there's ties? I doubt there'll be ties, but if there are, then we just randomly choose the best one to take. And now there's two cases, like whether like we visited it or not, like because like we never like with the preconditions, this node is always visited. So like if it's not visited, which means in this case, let's pretend that this one, simple recursion, this one's pretty easy. If we have visited it, right? If the node exists, if this node exists, I think I mentioned that like in the comments, it's undefined if and only if num visits is 0, right? So like if it has been visited, that means like the num visits is greater than 0, whatever. That means that like we just recursively search it, which is very straightforward. We just recursively, like we just kind of, wait, what? Yeah, there's no need to advance the state because like we already have the node. Like this node has the thing, like we've already advanced it. So we just kind of recursively apply it. That's pretty straightforward. And again, the whole negative business. Now here's the interesting case, right? When we have not, like we're, like this is the first time we've taken this edge, right? Like the num visits is not, it's 0. Like here it's not 0. Like we have taken it before, this node exists. But now here it is 0. Like the whole point is like, yeah, so now we're taking an edge which we've never explored, so we're kind of like hitting a new leaf, right? We're going to create a leaf. So first, we're going to clone the game state because it's important not to like, we want to like never mutate anything. Like we want to work with a fresh copy. Then we take that fresh copy, so like changes to here do not like mess up like the node, or else there'd only be like one game state, which would be stupid. Then we apply the move to it. Apply move. Okay, fair enough. And applying move would switch the player game state.isp1 internals. Toggle the, if I can just show that right there, right? Game state apply move, whatever, like game state.ts. When you apply move, right? At the end, we just toggle the turn. So like we're kind of advancing in all respects, not just the game state, like dropping the coin, but also flipping whose turn it is. So anyways, back here, we just apply the move, and then we kind of like, then what we do is like, so now applying move gives a new game state. So we take the new base, pass it into our neural network here with our model, and like do it. So then let's do create node, right? So this is like, and then once we do that, we just kind of like, we get the, like the whole point of all this is to get the value contribution, right? But now here we get the new node, we kind of assign it into here, so we no longer have to advance it. We're caching the node onto here. Like we're linking, like we're adding a new node to our graph. So we're changing the topology, we're adding a new node here. Fair enough. Again, create node, I'll go into detail, recurse inside, and then value contribution, we just get it. Again, this has to be negative, right? Like in create node at the end, we do a negative, that's crucial. But I'll explore create node later. Let's just assume that it works. Treat it as a black box. It's passes neural network from the game state, and then kind of like, it does a symmetry too, actually. And then we just kind of like get the node, which is kind of a wrapper around the game state, and like the edges, its own policy, right? Like we get the policy, and then yeah, it's just the initialize, whatever. It's just like this create node is analogous to like this stuff right here. If it's not in visit, because we've never visited it yet, we have to create it. Creating it and assigning it here is kind of like de facto marking it visited, right? So the whole point is like either we get like, we kind of recursively get value contribution, or we create it for the first time and then we get the value contribution. And then what we do is we kind of like take the value contribution, we add it to like, remember, the whole point was to like, from this node, we chose the best edge to take, right? We tie broke randomly. And now that edge to take is kind of has its own internal Q-score statistics, right? So we kind of add the value contribution here, the sum, like rather than storing like the average, like which this does, I feel like this recomputation is very kind of like stupid. I think it's better to just like store the sum, right? And then kind of like have this function here, get Q-score, which uses the sum and does it. It's just cleaner that way. Storing the sum and the number. If you have the summation, you have like the denominator, numerator, denominator, you just divide them, which is pretty standard stuff to get the average. Get it rolling till it's get a, just a accumulation of the Q-score sums. Then we kind of do all the num visits, but return -1. Okay, so everything made sense. I believe that the search is perfect, I think. Who knows? We'll debug. The only issue is like looking at your create node, right? If so now everything is contingent now upon this, the actual thing that like the meat, the actual thing that creates the node. The whole point of taking the model, right? This model in our search is to actually do some predictions, right? So let's see the predictions the model uses in the create node, right? And if to respect symmetries too, randomly. Okay, so then create node takes game status. Again, I've done this before, but I'm refreshing my memory. So game status, it's game status. So then if it is not, if it's terminal, like we want to like, that's the whole idea of like kind of like passing in true and terminal value. Otherwise it's default false and 0. That means false means we don't care about it. It's like hash, right? Because like here, if it's a terminal, we just kind of like do -1. Wait, what? Okay, yeah. Wait, then wait, hold on. Okay, I feel wait, no. There should be a negative sign here, right? Okay, let me just refresh. So it's in create node, right? If it's terminal, then what we do is, again, I mentioned how this is more generic to all games. Like we could say that like it's always -1 terminal value, because like if it ended, if the create node, like if it's player 1's turn and the game ended, that means like the guy who moved last, player 2, must have made the winning move. So from player 1's perspective, it's a lost game, and symmetric argument applies. It's without loss of generality. Same applies for player 2, but this is a more general case. I discovered this, right? So terminal value that we assign is from the perspective of the game state. Let's say, for example, that we're creating node from the perspective of like player 2, right? Like again, like here, put player 1, right? So player 1, we take the best edge to take, we choose that, and let's say it's a winning move. So player 1 chooses this edge, and then right when he's here, when he applies the move to the, and we create a next game state, the next game state is over. That means player 1 made a move and the game ended. So the game ended after player 1 made a move. That means player 1 either made the last move on the board and it becomes a draw, or player 1 made the winning move and got a connect 4 and won. Let's say that player 1, in this case, won. Because like the draw is simple 0, easy. -0, 0 makes no difference. It has no negative. It's just 0. Let's say then player 1 won. So now it's create node. Game states from the perspective of is player 1's turn is false. That means player 2's turn to move. And player 1 has won because player 1 made the winning move. So what is the value from the perspective of player 2? It is simply -1. So if game state player 1's turn, that's false because it's player 2's turn and it's -1. So this checks out, and then we've kind of flipped the negative sign. Okay, yeah, that looks good. And now this way, so now like we get the terminal node and we kind of cache this value. Again, this value is from perspective of this game state's player. That's the value. Then we return the node and then terminal value. Wait, what? Okay, so let's just say right now that player 1 has won, okay? Player 1 has won. So then we choose the action, and we've never seen it before. Let's say we see it for the first time. We apply the move. We get a game state that looks like player 1 won. Then we create the node, right? And what's the value contribution? What do you want the value contribution to be? We want this number to be +1 because from player 1's turn, he has won. But then from player 2's turn, the terminal value contribution is -1. And we return -1. Like we'd return player 1 won, so we return -1 as terminal value because from player 2's perspective, -1. But then we return that -1. Okay, let's say like even if this were not, how do we generally do connect node if it's not terminal, right? We just kind of like do the symmetry. It's the inverse policy, right? And then we get I explained this earlier. We just kind of like, we didn't forget the symmetry. The whole point is that we call the model, right? Like we take our model, get policy and value, and like, again, like the whole point, I mentioned the whole kind of inverse flipping before. I drew a picture of it. You can refer to past streams. But the whole idea here exactly is -1 times value. Like we have to do -1. Like the value, again, this policy and value is from the perspective of this game state's player, right? But then that player, right, is like the opposite player. Like when we did apply a move that advances the game state, it switches whose turn it is. So like that's why like in create node, like whenever like the terminal value, right, like whatever, either terminal value or value, whatever value for this perspective of the game state whose turn it is should always be negated. Like here we do negation because we want to return the value contribution, right? We return the value contribution. And again, the value contribution has like this nice property, like the nega max, the negation. The point is that, yeah, I think so the point is that like here terminal value is -1 when player 1 just made a winning move and now it's player 2's turn, but player 2 is like, hey, the game already ended, and then terminal value is -1. So if we return -1 here, right, then like this value contribution would be -1, and then our Q score sum would go down, but we want it to go up because we just got a 1. So then we should copy this -1, right? So that's one bug right there. Okay, I'm glad I worked that out. Again, this does not answer the error message, but there's just like a bug I think I just found right now. Just save that. let me just compile it. TSC status get diff. Okay. Get status. Get at all status. Okay. Anyway, so back to here. It's not this player's turn yet. So I think that, so now I think search and create node are perfectly done. I see nothing wrong with the search function. I went single, well, no, I have to still finish it. I've done all of these. Now it's the case where it's not. So let's just say for now that player 1 has traversed, and now like we've done this, everything checks out if it's terminal. And now let's say that player 1 makes a move that's not completely winning, but like 0.99, right? It's like a very strong move. It looks really good for him, right? So then here, let's just say that, so now we're not here. It's still ongoing. Like we exit this if because like the game is ongoing. It's not terminal. Then we get a symmetry. Let's just say that it flips it. Okay, sure. So then we get the policy and value of what? We flip the game state, right? And then we get the policy. Now remember that this policy that we got like from the like get policy and value, we have to reflip it back. Like the policy is applied to the flipped one, so we have to like inverse it to get the actual policy. And I've explained this. In the case of Connect 4, inverse policy and transform policy are the same function, in fact. You can refer to symmetry.ts to convince yourself of that, right? I mean, I already talked about that. Like if you look here, like it's the same flip policy, like this is the same exact function twice, right? So that's pretty, it doesn't even matter, to be honest, for Connect 4, but we should be specific if we want to generalize to all games or more games for generality's sake, inverse policy. So we have the policy and the value is pretty much the same. Like if the game is like winning and you flip the board, you rotate it, whatever, it's still going to be winning. Like if it's like a chessboard, like you walk around the chessboard, you don't change the outcome for like a given player, white or black, right? So value is the same, right? And then what we do, so like again, so like player 1, it's player 1's turn, right? So player 1 chooses a move, the UCB score. We have a really good move that's like 0.99 perspective, right? So now the game state's now player 2's turn, and then when we get this value should be negative 0.99, right? Because this is like the neural net will say, hey, it's really bad for a player 2. It's like negative 0.99. But then, and then we kind of like use that negative 0.99, and then we kind of like, what do we do with the value? I mean, yeah, I know we return it, but like, where do you like, the whole point is to create the node, right? So where are we creating the node? Yeah, so new game, so like we create the node. No. The node only has the game state and the edges, the policy, right? So like we get the policy from the perspective of player 2, right? Like what moves player 2 should move in such a pathetic game state, which is negative 0.99. So then this value is negative 0.99, but then we negate it so that from the perspective of player 1, the value contribution, which we got right here in line 81, I mean, after creating like the node, is like plus 0.99, which is good, which is what we wanted because it's really good for that. So the value contribution gets applied to like this edge to take and say, hey, like traversing this edge really improved our Q-score, gave us a nice Q-score contribution. So that looks good. Yeah, okay, I think I've convinced myself of the correctness of search and create nodes. So now let's just rerun this again, because I mean, let's just do a TSC for good form, and then run it again. Debug console. Let me just actually get rid of the breakpoints. Or wait, what? Yeah, here. Yeah, no breakpoints. Okay, good. Let's just run debug. Okay, should not see the messages. Okay, so then do MCS. So there's some issue in search. Somehow while we're doing search, apply move, we're getting some turn error, right? Okay. That's weird. It's quite weird. But let's just look. I mean, I looked through every single line in search and the associated create node. I see nothing wrong with it. So let's just start debugging. Wait, I think I hear something. Wait, what? Run and debug? Oh no, wrong. I have to run debug train.ts. So let me just drink some water. Okay, our breakpoint has read search, right? So let's look at our node. Our node. That's how do I get rid of this? I don't want to watch anything. So node has, let's look at the game state, right? It should be empty, all zeros. 6x7 grid, 6 rows, 7 columns. All zeros, great. It's not terminal. Okay, let's step over that. Again, the bug happens in apply move, right? Which is like somewhere here, line 78, there was an issue if like there's a mismatch of like wrong player's turn. Okay, best edge, whatever. Best edge score, min value. Okay, wait, 5E negative, wait, what? Wait, that looks wrong. It should be like negative infinity, right? Smallest positive number, not most negative. Oh, that's a bug. Negative infinity, is that it? Let me just stop this actually. Let me just fix that because this looks quite wrong to me actually. Save that. Get status. Get diff. Get at all. Get status. I was like, okay, fine. Okay. Anyways, back to where I was. Let's just put a breakpoint right here. Actually, no, I can step through it. Okay, that's fine. That's fine. That's fine. TSC. Oh, sorry about that. TSC. Come on, compile. Okay, good. Run debug. Wait, no, wrong file. Run debug, right? Okay, so then step over there. So now we have some edges, right? Let's look at our edges, right? No dot edges. We have 7 edges because we can drop in any of the things. And what are the probabilities of them? Well, they're all uniform because this thing has been randomly done. Convention. Anyways, okay, sorry about that. Let's just go back to negative infinity. Okay, I mean, sorry, breakpoints. Did I just close? Oh, no, okay, good. So edges, we have 7 edges. So then there should be like, let me just kind of skip over here because like they're all the same. Like nothing interesting. Okay, so what's the edge to take? Best edges should be a tie, right? Best edges is 7 because they're all the exact same probability. We just randomly choose one. Okay, so what's our edge to take? Our edge to take is column index 1. Fair enough. Sorry about that. Anyways. Okay. Edge to take, value contribution, 0. Okay, sure, why not? All good. Now we should get the else case because this never existed. Okay, now apply move, right? Game state? What's our next game state? What? Array 12? Wait, what? What? Wait, what? Okay, wait, so that's clone, game state. Game state. Wait, hold on, what? Anyways, right. So next, okay, so wait. So there's a bug here, obviously. Okay, let's just see what game. So let's look at our node.game state, right? Because that was all zeros, right? Where's our node? Where's our node? Where's our node? Wait, what? Why is your node undefined? I mean, that's the edge to take. Where's our node? Yeah, our node, right? If I look at our node's game state, it's just a 6 by 7. Again, the x by y, m by n is m rows, n columns. That's the convention, rows first. But the next game state somehow is 12. Okay, so something wrong already happened. Let's look at our GameState.clone function. Right? Let's just run debug again. Let me delete the one. What was the other one? Was this one? Okay, the other one was this one, 77. Wait, what? Search. Okay, yeah, whatever. Let's just run and debug it. Sorry, train.ts, we have to run debug. Okay, let's just skip past that one. Here, okay, let's step into that. Let's step into clone. Copy is new game state. Oh, I see the issue. So the issue is that like you're kind of appending more and more rows, which is like, yeah, okay, I see the issue. The thing is, we already have a bunch of empty cells. We want to replace them. Okay, we can just clear them out, right? That's just, okay, this is a pretty brute-fisted approach, but like we could like kind of edit them, or we can just, yeah, I'll just be like lazy and just kind of do like, I'll just be super lazy and do like copy dot cells equals an empty list. Let me just be lazy. In fact, I think we have to do the same thing too for symmetry, right? Because I kind of copied that from somewhere else. Let's go to symmetry.ts and then kind of like look at the when I see new game state, right? Whenever you see new game state, that's the lesson takeaway. You have to initialize that to 0, right? Like, where is game state.clone? Wait, let's get rid of that file. Let's get rid of well, let's get rid of this file. That's a JS file, client side, or it's a, yeah, whatever. That's client side. And then like whenever we have new game state, we have to kind of clear out cells if we're going to append onto it. Same thing with symmetry, right? We get new game state, you have to kind of copy that. So let's yank that line and then kind of paste that in there too. What? No, but flip, right? Because like what we're doing flipping is like we're kind of horizontally flipping that, but like we're kind of appending. So like same issue there, we have to do that. Wait, what? Flipped game state thought is P1 turn. No, wait, what? Wait, what? What is this line? It's just saying x equals x. That's a tautology. Actually, I think that's the bug. That could be the bug. GS, right? We have to do game state. Or else it's always going to be player 1's turn. So when we're applying the move, but then... Okay, I think I see the issue. Okay, that was quite... Okay, I think that should fix it. Or that's definitely a bug, right? When we're flipping it, when we're copying it, we have to like kind of do that. It's basically the same thing as like when we're cloning game state, right? You have to copy, like, you can't just like say x equals x. That gives you no information, right? You have to like copy it properly. Okay, let's just run it now. Let me just turn these checkpoints off and just kind of run it. Or should we just like put a breakpoint right here? Run debug. Debug console. It's not this player's turn. Okay, so there is still a bug. Okay, let's bring back those 2 breakpoints. Let's just bring them back. Oh yeah, I forgot to do TSC actually. I mean, just actually, no, whatever. Let's just leave them there. Oh yeah, wrong file. Do it for train.ts file. Okay, whatever, let's just skip to next breakpoint. Next game state.clone. So now let's look at next game state, right? Next game state is now 6, right? We've applied it at... Oh, it's just, we have this clone, we have to apply it. What's the edge to take? Let's see which column that with random luck is. So let's take column 3, okay. Well, technically column 4, because it's the 0 indexed. So now, right now, our next game state kind of looks like this. And 0, 1, 2, 3, we'd expect this to be 1, right? So let's see if that comes true. So now next game state, we applied the move to it, and indeed we see a 1 there, so that is correct. Now let's create the node. I kind of feel like stepping into this just to see it take place. So it's not ongoing, so we have to skip out of this if case, obviously. Let's apply symmetry. Let's see which symmetry we got. Well, I don't even care about that, because I mean, whatever, it's a very straightforward thing. Okay, so let's look at our policy and value, right? Policy. So our value is 0.01, so that's almost 0. So that's basically saying it's a draw. And then policy, what does it say? If you're player 2, because now the next game state's perspectives from player 2's turn. Players 1 has put a column in like column 4 or the third column index 3, and now the game state, like the person whose turn it is now changed. It's players 2's turn, and let's see what the distribution is for them, right? Moves and probabilities. Like each probability, okay, so they're basically about the same thing, except 1 and 2, the first 2 columns are a bit disincentivized. Everything else is pretty straightforward. It's pretty uniform. Okay, let's just kind of... Okay, whatever. We're going to return... Let me step out of that. That's perfectly fine. Okay, so it's basically the value contribution's like 0 point... It's almost 0, right? The value contribution's like negative... Again, it was 0.01, so slightly good for P2, but then when we do -1, we have to like negate that, because from our perspective, it is kind of a little bit bad, but almost a draw. So we kind of take our Q-score sum, and then, yeah, I've already worked through that. That makes lots of sense. So now let's look at so now after doing this bit of bookwork, our edge to take, right, which is the moves column index 3. So now it has some statistics in it. It has like 0.14 probability, right? I mean, well, all the edges have some probabilities. Like if you look at our node, right, they all have the same thing, 0.1428, right? If you look at our node, right, you look at all the edges, then the probabilities are negative. I mean, 0.14285. Yeah, they're exactly the same. Like the edge to take probability, yeah, that's fine. We care about the num visits. Num visits is 1, and our Q-score sum, again, it's not just our average Q-score. We have to divide like this by this to get the actual Q-score. But anyways, it's just a running total, and the negative sign makes sense. And the node, which we got, right, the root node, now we get 1. So the num visits, like these plus is tracked correctly, and we return -1. Again, from root node doesn't matter, but like it only matters for like the intermediate, like the non-root nodes, the propagation. Okay, so that looks good. Okay, wait, what? We just do it again 100 times? Let me just click play. Let me just turn these ones off actually and see what happens. Okay, now we've actually hit the breakpoint. So we've actually successfully trained everything, and like I mean executed one iteration of self-play, right? This num iterations is 1. Num games per iteration. Everything is just one game. We've successfully done one game, and we have some examples. Here are examples, right? Wow, it took, wait, what, 43? Wait, how can it be 43? There's only 42 squares. Oh, because of examples, right? Because examples, like, okay, so the examples from game should be half of that, right? Yeah, 22, right? 22, right? 20, like, okay, so game state -1, 1, right? Let's just look at the end, right? In fact, yeah, it might mean I see a bunch of random moves. So player 2 wins, we know that. Where is it? Where is it? Where's the win? Oh, I get the issue. The issue is this is the last one, right? Like, this is not the final game state. This is like the final example. And then the game ended, so we never actually added it. That's terminal. We don't care about terminals. These are all like non-terminals. So let's see what the probability was, right? Let's see what the policy was here. Like, given this situation, what happened? Okay, so move 4 was definitely played, right? Like, in this position, it is not player 1's, like, we know from like 0, the root node, that's -1, which means from the assign rewards, means that player 2 wins, because -1 for player 1, right? So then here's the last example we recorded, and that is, wait, what, is that the last? Yeah, that is the last. Wait, what? Yeah, 1, because this is 1 from the perspective of player 2. Like if you look, it's game state, right? The game state is player 1 turn is false, right? So like here, if you look here, the game state is player 1 state must be true because it's player 1's turn in the root when everything is all empty, right? So now we skip that, we go all the way to the end, and it's very clear from the policy. In fact, we can see like it says use column index 4, like 0, 1, 2, 3, 4, like 95% chance play here. Wait, why would you play there? 0, 1, 2, 3, 4. Wait, 0, 1, 2, 3, 4. Play here. Wait, why would you play there? It must have played here, like 1, 2, 3, 4, and column index 5. 0, 1, 2, 3, 4, 5. Why would it say play here? I guess. Oh wait, no, these are the move index. These are just the move object. These indices 0, 1, 2, 3, 4, 5, right? Because like we know that it should play 0, 1, 2, 3, 4, 5. It should play in the 5th column. It should play here to get the diagonal chain of 4. Column index 5. But it's saying do this 4. But this 4 is not wrong. It's the actual move index is stored. I mean, the column index is stored in the move. Because remember, like, this column is purely full, so the policy can never have it. So there's like an off by 1 error, right? Like if you look at this move, it must be for column 0. This move for column 1. And this move for column 2. And then this move for column 4. Because there's a skip, because the third one is all full, right? Exactly. So this 95% chance, right? This 95% chance, right? Corresponds to column index 5, right? So with 95% probability, we want to put it in column index 5, which is, again, correct, 0, 1, 2, 3, 4, 5. So here it's extremely likely, 95% chance, the player 2 drops it here, we got to connect 4, the game ended. And if you can look at the policy distribution, right, like, we have a neural network that literally just, like, kind of randomly gives us garbage, but because it's, like, by putting it there, we hit a terminal state, like, we kind of, like, we're witnessing Monte Carlo policy improvement already in action, right? Because we hit a terminal state, obviously. In fact, I think if I jack up the number of simulations from 100 to like 1,000 or something large, then like we get even more policy improvement. But anyways, where was I? Here, right? So yeah, I think that works. Then we await train model. So let's just step past that and actually train the model. Train the model. Error. Okay, let's just let it play out. Okay, so what's the error? You must compile a model before training, testing, use layers.compile. Didn't we do that? Didn't we do that in .NET? Model.compile. I guess when we're loading, we have to compile again. Does this have to copy and paste to compile? What does compile do? Specifies the loss function, the optimizer. Like, how do we do the fit? Like, we use SG, stochastic gradient descent. Like, that's how we train it. But shouldn't saving it, like, kind of save these things? So, have to compile your model again after running. That's Python, right? Okay, okay, for now, okay, whatever. Get status. clear, get diff. I can like use the version control thing from here, right? It's like CM for modify, presumably. Like kind of like look at that, right? Like see the wait, that's a different one. How do I? Whatever, I can just use the command line, which I'm familiar with. Yes, yes. Status. Yeah, I think the crucial thing actually was this thing right here, like this redundancy, which like that fixed the not the apply move turn, like should not happen, is wrong person's turn, whatever. Okay, so get status. For now, let me just kind of copy this. I mean, we know that like this compilation has worked for like an example to example, right? Like I tried using, remember there's a previous stream where I showed that for like a simple like linear regression example, just one neuron or one whatever, like one very simple example. So then when we're doing train.ts, right? Before training the model, we have to compile it, right? Something like that. Like this, right? Just put a breakpoint here, put it there, and do that. Okay, run and debug. Okay, so we have trained the model. Let's look at our debug console output. Epoch 1-1. And then we just got a bunch of like this whole thing is like in the net, right? In the net right here, what we have is we have like console log history.history. So like, yeah, so that's good. That's what we're seeing. And we saved the file, right? Boom, we saved it. And we're done. We're finished. We're now, like, this thing should be complete in theory. Okay. All right, that is good. Now let's just like tweak some numbers. I mean I think I could just end the stream and like kind of do stuff by myself, but let's kind of see let's increase this to like let's play 100 games. Let's see, because like that took very fast time, right? Number of iterations 1. Okay, let's just run it. Let's just turn off all breakpoints and look at our debug console output. Let's just run it. Right? Wait, what's it calling? Node train.js. It's done. Simple. Okay, let's do 5 iterations. Oh yeah, sorry, I have to actually do TSC to save it. Get status. Actually, let me just commit. Git commit sm. Hopefully fix bugs and now ready to train. I'll put an exclamation, actually no, just that. Status, git push. That looks good. How much battery do I have? Like I have lots of battery. That's good. Actually, let's go back to command line, right? Like we just kind of like do TSC, right? And let's do like node. Actually, let me just do the command line. I think the debugging is done, and we can go back to the trusty old command line. TSC, get status. Just because like all these things, like yeah, we notice that the weights have been changed due to training, right? Get diff. Clear. Too much clutter. Get diff. We're just tweaking the numbers and adding compile. Oh yeah, I should do that too. Get add all. Get commit. For training it with fit, because like fit is what model.fit uses in train model, which is imported from .net, right? Like that like kind of fit is what before training it, yeah, just before training it. Get status, get push, and I did some tweaks too. Get status, TSC again, clear, and then node. What's the command line? Just node train.js. Just node train.js. Let's just do which node. Let me just see which node I'm working with. NVM versions 20.2.0 bin node. Yep, that's correct. Train.js. So node train.js. Okay, it's taking a while. How long does it take this guy? Let me just kind of go on here. Okay, control 1. How long did it take him? 3 days. Okay, I cannot stream for 3 days. Okay, this is taking a long time. Am I still streaming? Yeah, stop. Okay, yeah, stop. Okay, fine. Should I just break out of this? Yeah, let's break out of this. Get status. Okay, yeah, okay, fine. That's fine. Okay, let me just go back here. And let's just go back and play less games, right? Or steps. Wait, the 100? No, that looks good. Whatever. What's the issue in train.ts? How many games am I playing? Let's just play 10 games in one iteration, right? Because I want to see these. I want to see some output in the command line, right? TSC node train.js. Okay, it is 6:01, 6 o'clock. Let's see how long. Okay, so right here, boom. We get 1. How many are we doing again? 2. We're doing 5. 3. 4. Okay, so loss is 2.947, 2.961, 2.93. So 3 is the lowest. 3.935, 2.92. Okay, fine. That's good. How long did that take? Just 1 minute or something like that. Let's just do it again. Let me just do it again. Drink some water. Okay. Oh, it's done? Oh, let's do it again. Okay, it's done. Get status. Clear. Just clear everything. Get diff. 10, 5, whatever. The main thing is that the binary, like the weights file is changed because we have trained the model. Okay, let's actually run it, right? Run.sh, right? Like, let's actually run it and play against our new bot, which is supposedly a bit better, right? Well, let's play against the bot. Well, let's see how much it's learned. Probably nothing, but let's just see. Let's find out. I'll go first. Play here. Play here. Okay, it's going to center a lot. Play here. Play here. Pretty bad. Okay, let's just go second. It goes here. Okay. Okay, so it seems to always like the center. Play here. Play here. Okay, it's doing something. I don't know, it could just be luck. Okay, yeah, pathetic. I just win. Okay, fine. Let's step it up, shall we? Let's make the number of iterations 20. Number of games per iteration, let's do 20. Save that. TSC node train.js, like that. Okay, so it is if you see this print statement, that means that, what does it mean? That means that we're straining it. So we did one set of 20 games. So we've done one set of 20 games. And each iteration, what we're doing, each iteration we're saving, right? So we have 1, 2, 3, 4. We're 1/5 way there because we have to do 20 of these. Let's see the loss function. 2.94, 2.94. What was it earlier? Like 2.97, 2.96, 2.91. So 2.91 is like the lowest. Okay. 2.95. Okay, so it's going the wrong direction. 2.94. Okay, so 1, 2, 3, 4, 5, 6, 7. I think he did 10 epoch, something more, whatever. To A3. Okay, so A3. That's a good. That's lower. 2.93. Okay, never mind. Okay. How many have we done? You know, I have an idea. Instead of like doing that, let me actually count it out. Let me actually like in the iterations, num iterations, right before ends, let's just console.log it. The number. In fact, let me just only do that. In fact, let me just clear the other clutters. We just see the number. Let's go back here and let's comment this in. Just for making my ease, just for ease of yeah, we don't like whatever history, whatever, right? Let's just do that. That looks good. Well, I'll wait until it's finishes, then TSC it. In fact, this is a lot. Let's just make it. Let's just go back to some small number again. Like later on, once I end the stream, I'll do it myself. I'll just kind of let's make this back to 10. Let's make that like 5 or 9, whatever. Or actually no, 10, whatever. Or 1, 0. Yeah, okay. Let's just make that 10. Because like this is taking a long time. In fact, let's just make it 5. Again, I'll wait till this finishes, then I'll do TSC. Actually, I'll wait till it finishes. I'll do TSC, but then I'll play it, and then I'll do it again. How many have we done? I have to do 20. It should be doing 20 of these print statements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, it's almost done. Just one more. 20. Wait, what? Why isn't it finished? Okay, it's done. Let's do wait, I added some changes, so then like clear TSC. Actually, what are the loss functions? 2.89, 2. Okay, no, whatever. TSC. I'm not sure what meaning I can describe from that. TSC to like to tweak in the constants, and then okay, yeah, get the whole point is this console.log, so you can see the number, right? Instead of having to like manually count everything, we just get 20. Or in this case, we now get number of iterations 5. Okay, yeah. Okay, now the binary file is like we did a whole bunch of training, so let's see let's play against it. Go first. Okay. Go here. I'm red. Here. Oh, it lost already by double. Okay, so it's trying to do central control. What happens if I let it? I'll go second, let it do that. Okay, I mean, I guess it wins, but... Okay, let's see if it can block me. Nope, it can't. What if I go here? Okay, so it only plays center. Wait, is that really it? Is that what it's taken away from this? Just play center? That's pretty sad. Okay, let's try to like prove it. Let me put it on top of it. Okay. Okay, now what you'll do when it's illegal. Okay, so it plays there. Okay, let's see if it blocks me. It does not. I mean, let's give it a chance. Okay, so it likes to stack. What if I play here, let it win? Will it do it? Yep, it won. Okay, so it kind of has... Okay, so it seems to be doing something, but... Okay, let me go first. I'll play seriously. Well, no, I can't. Let me go second. I mean, I could just stack vertically and win. Oh, oops, but... I mean, okay, yeah, let me just block that. And I'm saying I can still kind of like, I can just cheese it, but I'll try to play as if I'm playing someone intelligent. Okay, so it's fighting for the center. It's controlled. It's contesting the center. I'll go here. I'll go here so that I'm kind of creating some threats. I feel that I'll just go here. It looks visually appealing. I think here is a good cutoff. Actually, if he's here, he can't really do much except that. Because like, yeah, okay, I'll just actually... I don't know. I need to play a waiting move. Okay, he plays there. I'll have to block him. Wait, no, I have a forced win, right? No. Wait, no, I have a win here. Wait. Why did he play there? That's so dumb. I just play on top and win. But actually, I could have played here, right? Because this and that form of double attack. If I played here, he would have to block me, in theory. Then I would play here and win. So, yeah. Okay, I won. Okay, I mean, I guess something is happening. Right? I think so. Okay, fine. Get status. Clear. Get diff. What did I do? Yeah, actually, yeah, let me just run this one more time to like showcase this console.log in action. So, node train.js. And let's just see it work. Yep, so now it's like, wait, what? Okay, I guess this thing will happen anyways. So 0, 1, and it should go up to like 4, right? Or, yeah, 4. 1, 2, 3, because like 5 iterations, right? Isn't that it? 5 iterations? Yeah, 5 iterations. So 5 times training. Each set we play 10 games. Of course, I mean, I'm gonna probably like tweak this number, that number, this number, maybe this number. All these constants will probably be tweaked. I'll see. I mean, we'll have to increase everything. Well, I'm not sure what the CPUC, but yeah. What does Leela Chest use? I don't know. Okay, it's done. So 4, right? Get status, and then run.sh on it. So I say this is pretty successful. I think this is done. All that's left is just train this a whole bunch of times. So increase the number and leave it running. Sorry about that. Let's just go here, refresh, go first. Okay, is this all it knows, just doing that? That's pretty dumb. I mean, whatever. Let's just go second. Wait, I'm blue. Okay, I'll cut it off. Okay, fine. It's trying to go here. Let me let it. Let's see if it can do that. Okay, I want, even though I could block it, I want to see if it has the ability to block there or win there. Nope. 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 Oh, I just won by accident. Okay, never mind. Yeah, this bot's playing pretty badly, but I guess I have to train it some more. But yeah, so far it already understands to like kind of do that there. Because like for reference, just for complete reference, right? Like right now, let me just put a policy on myself, right? Let's just say I go first, second, it'll win always, right? Wait, what? Sorry about that. Like if I just go like 2 times here and 2 times there, it'll always win, right? And right here, 2 times here, just 1 time here, it'll always win. So the bot has kind of learned to control the center already. Whereas previously using random moves, right? Like I showed you, like if you just go get status, or actually let's just do, wait, clear, get diff, okay, get commit, log the iteration number. Wait, no, what? That, never mind. Get status, clear, get status, get add all, status, get status, get push. Okay, get status. All right. Okay, now one more thing is I have to make sure that I'm using the no GPU, like this thing right here. I think I should like kind of like go here and like use this no GPU, right? To make sure that it trains, like when it's actually like doing the train model, it should be using the GPU for training. So I'll be sure to like fix that later in my own time. But I think for now is a good stopping point. Like the bot has already learned to control the center. Like if you do git log, right? And like let's just check out like where were we last time? Today's February 28th. It's right here, right? If you check out this version, right? Just copy that, or A55D. Git checkout A55D, right? Yeah, this is where I was before today, right? And now let's just like run it, right? Like if you run the server using the other weights, like just to show you, let's just to like demonstrate, like if I kind of go back to my bot, right? Like now I'm saying it learned to control the center, but here it's playing randomly, right? It just blocked me, right? Like it's just oh, oops, I won. But like if I like go 2 times here and 2 times there, it's basically randomly moving. Whereas like if I just like get status, get pull, just fast forward, whatever. Wait, what? Git check. I'm not like a Git magician. Status. Clear. Git status. What did I just do? Origin main. status. Wait, head to tap. Sorry, what is this? Get checkout main. So it's main. Get status. Get pull. Make sure that I'm clear. Okay, good. Get push. Make sure that there's nothing to do. Okay. And now run.sh. Okay, now this is the stuff like back to being up to date. Control 4, or no, Control 5, Control 6. Okay, yeah. Now let's go back to like playing with the bot learn center, right? If I go here, and then here, the bot 1 center, right? Player 2, here, I don't know, here, and the bot 1. So now like the bot has showed some proclivity towards the center already. Okay, I'll stop now. Get status. Okay, I think we're done for now. Like, I feel that like, yeah, I feel that satisfactory enough has been done. I think that we're finished. I think that largely most is already done. Like, let's just actually look at the changes that were made, right? Let's see the changes. So, like right now it was last month, January 30th, but now today, almost a month later, I did a whole bunch of things. So let's like look at everything. tsconfig, that's just the map files for VS Code to like do the debugger thing. Train, yeah. So like here map files, symmetries, because like we have to actually use the symmetries to like data augmentation. I think I used to call data, yeah, it's augmentation of data to like generate more data for like to make it generalize better by leveraging the symmetry of like flipping the board about the vertical axis. Then we kind of, it's not just enough to train it, but we actually have to save it to the model file. And as we learned by saving it, we've kind of taught it to like the center. Then we invoke the train. Then we return the examples because we have to actually return something. VS Code showed me that, but I pretty much figured it out. Like, to be honest, like probably like earlier, like before stream, because like at the end of last stream, like, hey, wait, I'm not returning these examples. Source map. Okay, that's a good comment. That's a good commit. Okay, so now next one. Let me just open them into new tabs. Here. Well, this one is pretty dumb, just iteration. So like fix bugs, this is the main commit to use. They should see this one. Just like we compile it just to get rid of the error because it's not saved, I guess. And here's the main commit to exam. Like, hopefully fix bugs, now ready to train. Well, I guess this was almost there. All it needed was one little thing with the compile model, but otherwise it was almost hopefully. It was like 99% of the way there. So this thing is a bug fix. We have to clear the cells because like we're just kind of like pushing. We can't just like push. It's like we have to like first clear it out and then append. Okay, what else? That's the only thing for game state. And then I think symmetries too. Yeah, symmetry. Same exact thing. Except I noticed something very crucial. I got extremely lucky here, but it's really dumb that I would do like this is such a flagrant violation of common sense. Okay, so that one done. MCTS. Negative infinity, yeah, good catch. Min value made 0 sense. I mean, it was like such a small number. I guess like int.min value in Java is like 2 to negative 32. I mean, negative 2 to 32. And then positive is 31. No, sorry, 31 because it's 32 bits. So like we split up that 2 to 32 space into 2 halves. So it's like negative 2 to 31 and then like 2 to 31 minus 1 because, yeah. That's this 1 less positive and 2's complement. Anyways, the point is that negative infinity, that's crucial. So that's an important bug fix. Then negative 1, we have to negate it because like the terminal, like the point is like there should always be a negation at the end of like, at the end of this create node function, right? Like create node function, hash return from the prospective player whose turn it is not. That's crucial. That's why we were missing a negative 1 value, right? Wait, what? This is already done? No, in create node. This is in create node. Yeah, let's go here to expand, right? Wait, what? Yeah, exactly. In create node value contribution, which again is always from the perspective player whose turn it is not. Right? So create node, we have fixed it by adding a negative 1, which was missing, so that's a very important fix. I'm kind of worried what if I've like missed something, but like I've gone over by hand every single thing, and I do not see like I've just done that. Like I do not see anything wrong. I may have to go through each file individually, but so far it seems good. I mean, I'll just like let it train some more. Maybe like even like tweak the neural network architecture if I have to. I don't know, like increase numbers, change like hybrid tune, like hyper parameters, just tweak stuff a little bit. But I'll see where this goes. So -1 times terminal value, then policy value for symmetries. We fixed an undefined because this model gives you undefined. That's good. I mean, yeah, that's all for this file. There's nothing more to be done. Just the -1 and like fix this undefined to pass in the model correctly. Then symmetry, same thing as game state. We just kind of have to do that and like make sure like who's like the turn tracks correctly. Like, well, when we're doing the symmetry, like here it would always be like what, like new game state. It would always be player 1's turn is always true. But now it should be like we should respect the game state. Like the point is that like the game state's player, player whose turn it is should always be true to the game state. Like this should flow properly. So that's good. And then here just forgot the file, I guess, because like this one is fetched, like it works from browser, but then if we're using the file system like node, we have to stick in the file. And that's all. That's good. Okay, I think I'm pretty satisfied with all the work, so I should just end it here. And then next stream, like in between now, I'll just like let it run for like how many days? 3 days? I mean, that was for Othello, which is a 6x6, I think, or something smaller. So I think I have to run it for more. But no, I mean, this is a MacBook, right? Like this is a bit more. I mean, this is like 2017. So like it's been like what, like 7 years. So like the M1 chip or whatever. So like I'll just train it for like a few days. We'll see how long until it can like beat me or whatever. And like right now, the actual code that we're using, right? Like the code that we're using, branch main, yes, there's only one branch actually, is like in our bot.ts. In fact, I could probably remove the bot, but like the whole point is that the bot.ts policy get highest probability move. Like that's what we're doing. Like I could run a Monte Carlo tree search, right? Like I could run MCTS again, just like we're doing in training, like do MCTS, like in train, right? Like when we're doing the self-play function, like we're actually like getting a policy and we're kind of like sampling a move. I mean, we could just do the best move too, actually. I think like there's something called like a temperature parameter where like as the temperature changes like more and more towards the end game, the higher temperature or lower, whatever, it becomes an argmax basically. And like we end up like choosing like the best move. Like in the beginning stage, it's more open-ended, so we sample the move with uniform probability. But then as the game goes on and on, I think the temperature parameter in the Monte Carlo tree search, the UCB stuff, the temperature, which actually gets adjusted, and it basically becomes argmax. Towards the end, we just always choose like the highest probability. But there isn't. But the point is that like the game, what it's doing right now is like a depth 0, right? It's just a reflexive agent. All it does is that like the bot, like in our training, we actually do a Monte Carlo tree search. We do what, like 100 or some iterations, like 10. What is it? We do 100 simulations. I mean, 100 trajectories. Like we kind of like, what is that? 7 squared is 49, right? So it's at least a depth 2 search. Like there is some, like we build a tree, we get some depth. So like we're doing some search. We're not just like outputting what the neural network spits out at us when we're doing training, but then when we're doing the actual like when we're doing the actual the bot, right? Like when the bot is playing the game, we're not doing Monte Carlo tree search. We're just passing in our game state and we're just getting the policy, and from the policy, we're just ignoring the value. We're just straight up getting the argmax, the move that gives you the best probability, and we're just playing that move. So it's like a depth 0. Like we're just plugging into our network, and like we're not doing any future, we're not considering like building a tree, we're not doing alpha, beta, minimax, pruning, we're not expanding stuff out, looking at future states. We're just taking our state and we're just boom, like getting like just an instant policy, like an instant action recommendation. We choose the best, most recommended action of neural network and play against that. I mean, maybe I could like kind of like use MCTS here, like add some parameters or like delete this bot class or like add some like settings. Maybe the player can like choose how many Monte Carlo tree search simulations. I mean, if his GPU, if his like computer's pretty like low spec, maybe like just do this. Like we'll let the players like in BumperCoins, maybe like they can like choose the hyperparameters for like the actual gameplay. But yeah, for now, I just want to like, I'm deliberately just doing the weakest option. Like I'm not doing a search intentionally, just so I can like test the raw strength of the gameplay strength of the neural network. Because like if it's standalone, gives decent performance, that'd be amazing. Because like the actual inference, like calling model.predict for BumperCoins could take like a long time. Who knows? And like if it's like 60 FPS, like you want something kind of fast. You won't have enough computational budget to like search to like do a big search. So I do think that like it's important to have a strong network. So that's why I'm kind of like leaving this here just for the policy. Like just for the neural network strength alone is being tested. Like, and we're not bolstering it by Monte Carlo policy improvement. We're just using what the network outputs at us. Because that's how I want to do for BumperCoins. I don't want to rely too much on like searching. I want like the whole point of like using AlphaZero, the whole point of like this whole deep learning thing is like so that this network has strong game strength or has some understanding or some semblance of understanding, some imitation of understanding. So when someone plays against you, oh yeah, this opponent is playing reasonable moves. Like like we're pretending to have some understanding. Because again, everything is smoke and mirrors at the end of the day, right? Okay, I think that's all. It's getting really dark now. Like, it was, like, kind of bright when I started. Like, yeah, I can't even see my face now. Yeah, I'll stop. Yeah, I'm pretty pleased. I think that, like, all the hard work's already been done. Now it's just, like, debugging and, like, stepping through. And I mean, I may do it in my own time, step through, see if I find any more bugs, and I'll do that next stream. But I hope that next time I stream, like, I hope that, like, I'll get a good bot to play against, and I can even, like, maybe share it and, like, maybe, like, make it public. Like, create a website for anyone to play against this bot. And again, like this code will be all open source for Connect 4. Like every single keystroke, every single thing I've done, like all the commits are right here. So yeah, I mean, I think that like this looks promising. The only question is like how long this will take because like BumperCoins is way more complex than C4, Connect 4 is. So yeah. All right, yeah, I mean, it's dark. I should stop.